Hey guys, and welcome back to Miss Chemistry, and today we're going to go over biodiesel. Now biodiesel is very important. It's more application exam question-y type, so we're going to do some exam questions today on biodiesel. So what you're seeing here in the screen right now, this is, for example, this is a vegetable oil they give in the question, right? So, and then there's an ester, and then this is the ester. So yeah, vegetable oils have esters, right? And it reacts with methanol, which is shown here, methanol. And it creates glycerol, which is propane 1,2,3-triol, because there's hydrolysis. Remember, there's hydrolysis happening, which is because the carboxylic acids here, they're cut off. So hydrolysis, they're broken down. Bye bye. And then it creates biodiesel. Now biodiesel is a mixture of methyl esters of long chains of carboxylic acids, right? And biodiesel is important in AQA and in general, okay? And then this process right here is called transesterification. So I have problems saying this word. Transesterification. Now, transesterification is the process of converting one ester, which is this, of converting one ester into another ester, which is this ester, because biodiesel is made up of methyls of esters and carboxylic acids. And we're going to do exam questions on this today. So, yeah, let's get into it. Okay guys, so you can pause the video and do the question that is shown right here, and in a few seconds I'll go through it. Okay, so let's read the question. So this can be hydrolyzed to make soap. Clue, saponification, and can be also used to produce biodiesel. How is biodiesel produced? Vegetable oil plus, let me hear it, methanol. Okay, methanol. Write an equation for the reaction of this ester with sodium hydroxide to form soap. Okay guys, remember saponification? It is when a triester reacts with sodium hydroxide to form soap, which is a sodium salt, and glycerol. Okay, so let me zoom in because I need to write. Okay, so obviously, it already says it reacts with sodium hydroxide, so sodium hydroxide. And there's 1, 2, 3 of these, like 3 of these bonded together. So we need 3 sodium hydroxides to break all of those fatty acids, right? Sorry. Okay. Now, this is the part where you need to draw in reverse, okay? This is what most students get wrong, right? And this is only 2 marks, so you're gonna get this right. Okay, when we mean writing in reverse, guys, okay? So basically, example, you see this here? You see that in red? You're gonna draw it in reverse. Write it in reverse. Write it in reverse. So that's gonna be C17H31. And then you write everything else the same up until there. Because remember, it forms a sodium salt, and that sodium, which is positively charged, and the ester with the oxygen here, this oxygen is the C-double-O. This one is the ester oxygen, okay? And this ester oxygen is negatively charged, which is attracted to the positive sodium ion. So C-O-O-N-A. That is literally it, okay? That is literally it. Literally. That's literally it, okay? So, yeah, if you watched last video, you would understand it. If you don't, go watch last video. Okay. And then we can carry on just doing the same. C-O-O-N-A. H29 C-O-O-N-A. And remember guys, how is soap formed? What is the last thing that's formed? Glycerol. Glycerol. And that is CH2OH, CHOH, CH2OH. Guys, glycerol should be like, you should know, it should be a reflex arc action already. Glycerol, I know what that is. I know. Okay. Next question. Give the formula of the biodiesel molecule with the highest MR that can be produced by reaction of this ester with methanol. Guys, with methanol. Okay, big clue. So we already said that biodiesel was formed by, the vegetable oil, which is a triester reacting with methanol, forming biodiesel and glycerol. So the highest MR. Okay, let's cook. Let me cook. Okay, so let me rub this out. Okay, this is very easy. The highest MR would obviously be this one. Guys, it would be this one. Wait, is that highlighter? Sorry. The highest MR would be this one here. Why is that? Because they all have the same number of carbons, 17 carbons, which is here, in this line. But they have different numbers of hydrogens. So we want the highest. We want the highest fatty acid chain. We want those fatty acid chains, guys. Those thick fatty acid chains. Yeah. Okay. So, which one has the thickest fatty acid chains? Which one has the circumference of the fatty acid chains? This one. That one. It has 33 hydrogens. That's too big. Okay. It has 33 hydrogens. That's why it has the highest MR. It has more hydrogens than these other ones. So, now we need to write it in reverse. So, if you guys didn't do this question, I want you to write it in reverse. But remember, guys, it reacts with methanol. So, big clue when you write it in reverse, okay? So, basically, you'll be C17H33 COOCH3. Did you guys get that? CH3. The reason why it's CH3, okay, let me go back to the last model I showed you. Guys, look. This blue highlighted CH3 here from the methanol to the biodiesel. That is why. That is literally why. Because this CH3 is from the methanol and it wants to form the propane 1,2,3 triol. Okay, because it forms an alcohol as well. So therefore, with this biodiesel, it has the CH3 from the methanol. Okay guys, so I want you guys to go through this question again, and you can pause the video and then I'll go through it. Okay guys, so I'm going to go through it right now. So the slowing down of chemical process is important in food storage. Over time, fats may become rancid. This involves the formation of compounds that have unpleasant odors and flavors within the food. Hydrolysis of fats is one way in which rancid flavors are formed. Fats break down to long carboxylic acid and glycerol. Clean the right side of how hydrolysis affects. Okay, so what is our clue here? Aha! Look, I have found it. Water. And what does that mean? Acid hydrolysis. Because when a triester reacts with water and it says hydrolysis in the question, guys, hydrolysis. What is the hydrolysis reaction that we know? It's when an ester reacts with water. Acid hydrolysis, baby. That's what it is, okay? So this means if it's acid hydrolysis, an ester and water which undergoes acid hydrolysis in the presence of an acid of a hydrogen ion, this means it creates a carboxylic acid and an alcohol. So the answer for this would be, hold on. Okay, it would be CH3 CH214 COOH. Now the reason for this is because you know in this ester here, you can see in this ester that there's the ester oxygen. This is the ester oxygen. This is the C double bond oxygen. Okay, and then obviously it's good hydrolysis. It wants 3 carboxylic acids because there's 3 of these. So basically, we need this part, right? So then it's going to be left with the C double bond O. And what is in a carboxylic acid? Remember? An OH. The OH bond, guys. Remember the OH bond. Okay. Which is why there is an OH right there. And you just copy the rest of this molecule. So then we have our 3 carboxylic acids. And it also creates an alcohol. So since we have that, this means, sorry, change color. Since that molecule is broken off, the red part is gone, bye bye. We have this now, so we have these. And guys, remember, an alcohol basically looking like this. We have our ester oxygen left in these molecules, which means it's gonna have an H at the end. So basically, the answer is basically just writing CH2OH. See this, sorry, wait. So this one's referring to this one right here, CH2OH. And remember, it's just like, you know, like glycerol. Like, you know how glycerol is like this? Like you know how that's like glycerol? That's, oh, it's basically glycerol. It's basically glycerol, guys. It's basically glycerol. Then CHOH and then CH2OH. That's it, guys. That is literally it. Okay, next question. Other than by cooling, suggest one method that would decrease the rate of hydrolysis. Okay. Okay, guys. Decreasing the rate of hydrolysis. Think about if you do A-level biology, think about enzyme reactions. How do you reduce enzyme activity? What increases enzyme activity? Temperature. Temperature increases enzyme activity. Temperature increases hydrolysis. Temperature increases the rate of hydrolysis. So what would decrease the rate of hydrolysis except cooling, obviously? Keeping the food dry. Because if it's dry, no water, no nothing to do hydrolysis. It's dry. That food is dry. Them legs are dry. The knees are ashy. They're dry. There's nothing. So yeah. Okay, this would be like the last question we will do. Esters are produced by the reaction of alcohols with other esters. Oh wait, sorry. You can pause the video and do the question, and I'll go for it, obviously. Okay, I'm gonna go for it. So the esters are produced by the reaction of alcohols with other esters and by the reaction of alcohols with carboxylic acids. Okay, so basically, guys. Okay, so biodiesel. Remember, biodiesel is formed from vegetable oil, which is a triester, with methanol, which forms the biodiesel, and glycerol. So I basically said the answer. So it'll be 3 methanols. So 3 of these methanols. Hold on, I forgot the 2. Oopsies. Okay, so 3 methanols, and it'll just be glycerol. Oh my gosh. Guys, it's like, don't know how late it is right now. CHOH. There we go. Okay, write an equation for the complete combustion of C13H35COOCH3. Okay, so combustion is when you react with oxygen, which forms carbon dioxide and water. I think that's like chemistry basics. C17H. So let's just write this here. COOCH3 plus oxygen. Okay guys, so obviously we need to balance it. So there's 19 carbons on the left hand side, so we need 19 carbons on the other side, and then we have four oxygens on the left hand side, we have 3 oxygens on the other side, so we need to make that equal. And also on the left hand side they have 38 hydrogens, we only have 2 hydrogens, so we need to make that 38 hydrogens, so 19 hydrogens. And then now we can balance the oxygens. So now there's 38 plus 19. There's 57 oxygens on the right hand side. So you need 57 oxygens on the left hand side. So that is gonna be wait, let me make more space for it. That's gonna be 27.5 of oxygens. Or you can write 27.5, doesn't really matter. But yeah, that's it, guys. And the rest is other topics with these questions. So yeah, hope this video helped, and I'll see you guys in the next video.